All right, so I want to go over this example again, and it's not nearly as long as it was turning into. Somewhere along the way, I made an error. So let me go over this correctly. So we had this function, and what we're going to do, we're going to rewrite it as e to the natural log, and then just our function. Now, what this lets us do, the reason we like to do this, it allows this exponent to hop down. This is a result of one of the rules with logarithms and natural logarithms. So we get something like this. Let me make this look a little more exponent-like. And so our limit, well, it's just going to hop on up here because you can take the limit of a function that's acting as an exponent. And if we try to take this limit, take a look at it, we're going to run into problems. And what we're going to get is a negative infinity times 0. So this is an indeterminate form. So what we're going to want to do is we're going to want to use L'Hopital's rule. Now to set this up though, we need it to be 0 over 0 or infinity over 0. So what we can do, we can rewrite this. Like so. And in fact, we could simplify this a little bit. We get something like this. And this will become the limit as x approaches 1 plus. We can rewrite this. 1 minus x over 1 over the ln of x. This simplified will give us this. And this is going to be the indeterminate form of 0 on top. And on the bottom, this is going to infinity. 1 has got an infinity underneath it. It's going to be 0. So we have an indeterminate form, 0 over 0. That means we can use L'Hopital's rule. So let's take the derivative of the numerator. We'll get negative 1. The derivative of the denominator, minus 1 over the ln of x squared times the derivative of the natural log of x, which is 1 over x, minus 1 over x ln of x squared. So now we're going to take the limit with our new numerator and our new denominator. Negative 1 over negative 1 over x ln of x squared or this will just become x ln of x squared once you simplify this. The negatives will cancel out. This will flip, and we're going to get this. And now we can do our substitution. We can treat this as 1 times the natural log of 1 squared, or 1 times 0 squared over 0. And that's going to be our answer. Any questions? Let me know.